Welcome to our channel, fellow explorers of the cosmos. Today we're taking a deep dive into the mind of a true titan of science. Albert Einstein. Forget everything you think you know, because we're about to unravel 10 of his most groundbreaking discoveries, ideas so profound they shook the very foundations of physics and redefined our understanding of the universe itself. Get ready for a cosmic roller coaster, because we're talking about things like the nature of light, the fabric of space-time, and the mind-bending world of quantum mechanics. We're talking about equations that redefined reality as we know it, and concepts that continue to push the boundaries of human knowledge. Don't forget to subscribe and hit the bell icon for more amazing content. We're just getting started, and trust me, you don't want to miss a single mind-blowing moment. Okay folks, buckle up, because we're starting with Einstein's most famous brainchild, the theory of relativity. Now, before you break out in a cold sweat, just remember relativity is all about relationships, specifically the relationship between space and time. See, before Einstein came along, everyone thought space and time were like a cosmic stage, unchanging and absolute. But Einstein blew that idea to smithereens. He showed that space and time were not separate entities, but rather two sides of the same coin. Space-time, and this space-time wasn't static. Oh no, it could be warped and curved, especially in the presence of massive objects like stars and black holes. Now, let's shine some light on another one of Einstein's brilliant breakthroughs. Literally, this is the photoelectric effect, and it's all about how light interacts with matter. Back in the day, physicists thought light was just a wave, but the photoelectric effect showed that light could also act like a stream of tiny energy packets called photons, like little bullets of light. This discovery was a game changer. It laid the foundation for quantum mechanics, a whole new branch of physics that governs the bizarre world of atoms and subatomic particles. And you know what? It even earned Einstein the Nobel Prize in Physics in 1921. Ever looked through a microscope and seen tiny particles just jittering around in a fluid? That, my friends, is Brownian motion, named after botanist Robert Brown, who first observed it. But it was Einstein who explained what was really going on. He figured out that those tiny particles were constantly being bombarded by even tinier water molecules, causing them to dance around in a seemingly random way. This wasn't just a cool observation. It was proof positive that atoms and molecules, the building blocks of matter, actually existed. Chapter 4, EMAMS2, the world's most famous equation. Okay, time for the big one, folks. The equation that changed everything. EAMC2. Now, don't let the simplicity fool you. This little formula packs a wallop. It tells us that mass and energy are actually two sides of the same coin. They're interchangeable. In other words, mass can be converted into energy, and energy can be converted into mass. This discovery was absolutely revolutionary, leading to the development of nuclear power and giving us a whole new understanding of the incredible forces at play in the universe. Chapter 5. Bose-Einstein, condensate, a new state of matter. Now get ready to have your mind blown again, because we're diving into the bizarre world of Bose-Einstein, condensate. This is a state of matter that happens at extremely low temperatures, almost absolute zero. Einstein, working with physicist Satyendra Nath Bose, predicted that at these ultra-low temperatures, atoms would start acting very strangely, behaving like one giant superatom. This prediction was so out there that it took decades for scientists to actually create a Bose-Einstein condensate in the lab. But when they did, it opened up a whole new realm of quantum phenomena to explore. Chapter 6. The quantum nature of light, wave, or particle. Both. Remember that whole photoelectric effect thing we talked about earlier? Well, it gets even weirder. Einstein didn't just show that light could act like a particle. He also proposed that light has both wave-like and particle-like properties. This mind-bending concept, called wave-particle duality, became a cornerstone of quantum mechanics. It means that light can act like a wave, spreading out over space, but it can also act like a particle, localized in a specific point. It's like light can't decide what it wants to be. Talk about an identity crisis. Chapter 7, Special Relativity, the Universe at the Speed of Light. Hold on to your hats, folks, because we're going back to relativity, but this time we're going special relativity, that is. Now, remember how we talked about space-time being relative? Well, special relativity takes it a step further and throws in the speed of light. Einstein realized that the speed of light in a vacuum is constant for all observers, no matter how fast they're moving. This seemingly simple observation has some mind-boggling consequences. It means that time slows down as you approach the speed of light, and that nothing can travel faster than light itself. Chapter 8, General Relativity, Gravity gets an upgrade. If you thought special relativity was wild, get ready for general relativity. This is Einstein's masterpiece, his magnum opus, where he tackles the very nature of gravity. Forget Newton's idea of gravity as a force. Einstein showed that gravity is actually the curvature of space-time caused by mass and energy. Imagine a bowling ball on a trampoline. That's a massive object warping the fabric of space-time. Now roll a marble across the trampoline and watch how it curves around the bowling ball. That's gravity in action. General relativity has been tested time and time again, and it always comes out on top, explaining everything from the bending of starlight to the existence of black holes. Chapter 9, Unified Field Theory, Einstein's Unfinished Symphony. Even a genius like Einstein had his unfinished masterpieces, and his quest for a unified field theory was one of them. See, Einstein dreamed of finding one elegant theory that could explain all the fundamental forces of nature: gravity, electromagnetism, the weak force and the strong force. He spent decades searching for this holy grail of physics, but ultimately it remained elusive. Even though he didn't succeed, his pursuit of a unified field theory continues to inspire physicists today as they grapple with string theory, quantum gravity, and other attempts to unify the universe under one theoretical umbrella. Chapter 10, The Cosmological Constant. Einstein's biggest blunder. Even geniuses make mistakes, and Einstein was no exception. When he first applied his theory of general relativity to the entire universe, he ran into a problem. His equations predicted that the universe should be either expanding or contracting, but at the time everyone thought the universe was static and unchanging. So Einstein introduced a fudge factor into his equations, the cosmological constant, to keep the universe static. Later, when astronomers discovered that the universe was indeed expanding, Einstein called the cosmological constant his biggest blunder. But hold on, the story doesn't end there. Decades later, scientists discovered that the expansion of the universe is accelerating, and guess what they think is responsible? You got it! The cosmological constant. Outro: Einstein's Legacy, A Universe of Wonder. Thanks for joining me on this incredible journey through the mind of Albert Einstein. From relativity to quantum mechanics, his discoveries revolutionized our understanding of the cosmos and continue to inspire generations of scientists. If you enjoyed this exploration of Einstein's amazing work, give this video a thumbs up and share it with your friends. Let's spread the love of science and keep those cosmic conversations going. Don't forget to subscribe to our channel and hit the bell icon so you never miss an update. We've got a whole universe of fascinating topics to explore, so stay tuned for more mind-blowing adventures in the world of science. See you next time.